So for question 2, we were given this graph and had to determine basically all of this stuff. Sound of speed, or the speed of the sound in air. It's pretty easy. It's just 331, which is the standard at 0 degrees Celsius, times the square root of the new temperature in Kelvin, which is 27 plus 273.15, and then over what 0 degrees Celsius in Kelvin would be. And then, that just gets you 346.97 meters per second. Then we were asked if the pipe is open, or open, closed. So it's open, and we can tell because from what's labeled as the fundamental peak, if you multiply the frequency by 2, you get a peak, and if you multiply it again, if you multiply this by 3, you get another peak, and 4, and so on, but 4 isn't really shown. That only happens if it's open, whereas if it was open-closed pipe, then you'd get a peak here at the 500, and then a peak at the 1500, but not at the 1000. And then it asked what the fundamental frequency of the pipe is, and while it says it's right here, because this is the first peak, the fundamental peak is the very big one right here. At about, I just evened it out and said 1004 hertz. But then I also put 1004 hertz as the answer for D, for the first overtone. The length of the pipe, well, to calculate that, I used the formula for frequency, which is frequency equals velocity over 2 times the length corrected of the pipe. So then rewriting that, you get length corrected equals the velocity over 2 times the frequency, which is just what we wrote, or what we got for the sound of speed. The speed of sound in air, and then divided that by 2 times the fundamental frequency, which is 1004, and we got 0.173 meters as the corrected length. And then from there, you find the length by rewriting this equation right here as this. So we got L equals length corrected minus 1/3 times 2 times 0.03 meters, which basically is just this minus 0.02 meters, and you get 0.153 meters as the actual length of the pipe. And then question F talks about changing the fundamental frequency of the pipe by a factor of either 2 or 1/2. So yeah, if you close off one end of the pipe, the fundamental frequency would be half that of an open pipe, which would make the resonant frequency about 502 hertz.